Hello everyone, welcome to part 3 of the PowerBox iServo series of videos. So in this video, we'll be taking a closer look at programming the servos via our core or Atom transmitters. So one of the things to be aware of is that this particular servo is connected to a receiver using the P2 bus protocol. So just be aware that if you're using it in a standard PWM configuration, you cannot communicate with the servo because PWM doesn't allow any sort of bidirectional comms to any device. However, if we connect it to the P2 bus, which is predominantly the best way of using these servos, especially for larger aircraft, you have access to the telemetry features of the servo, as well as being able to program a number of parameters from the comfort of your TX, if you are a PowerBox core or Atom user. So in front of us, we've just got a basic telemetry screen for my receiver. I'm just using a PBR9D, and this servo is just currently plugged into the P2 bus port of that receiver. I've set up a secondary screen, or secondary telemetry screen, and at the moment I've got no other widgets except for one single servo output widget. So this is indicating channel 1 output from the transmitter's perspective. So with my throttle full up, or full throttle, I've got plus 100% travel, and full down I've got negative 100% travel, and in the middle I've got 0. If I get my stick in the middle there, it's close enough to 0. So I've just set up a standard channel 1 plus or minus 100%. The default programming channel allocation for this servo is channel 1. So out of the box, when you buy these servos, they're designed to respond to any communications that are specific for channel 1 on the P2 bus. Of course, you can program it for another channel. So if you're using a core, you can use up to channels 1 through to 26. Doesn't really matter. But for this example, I'm just using channel 1. Later on, I'll show you how to change that channel allocation. Now, this servo has telemetry. It also allows us to program it. So how do we go about programming the servo? Well, we need to set up a telemetry widget because we access the programming menu from a telemetry widget. So pretty much all core and Atom users should be very familiar with this process, but let's set up a telemetry widget for this servo. Now you notice in this particular screen we've got servo, but we don't actually use servo because this little menu item really just allows us to select a little box like this, which shows you the output for a particular channel, if you like, within, as far as the transmitter is concerned. So that's really a transmitter specific widget. So really, this is monitoring channel 1. So that's the output state of channel 1, which is tied to my throttle stick. So again, I just set it up for simple plus and minus 100% travel, with 0% being in the middle. So let's set up a widget for the actual servo. To do that, remember this is a telemetry device. So when we plug it into the P2 bus, it's not really treated like a servo, it's treated as a telemetry device from a data perspective. So we click on telemetry and we're going to add a sensor. So you can see there in the sensor list, we've got the PBR9D, which is the receiver I'm using. We've got the core transmitter, and then we've got this particular servo. So let's select the servo. And then on the right hand side, you'll see a whole lot of telemetry options available excuse me, for this servo. So we've got voltage, current, temperature, torque, position, rate, and status. So let's pick voltage. Click on OK. Click on OK. And there you have the voltage being applied to the servo. Let's make 1 or 2 extra widgets. Same servo. Let's pick on, say, position. That's an interesting one. So this will give us our position in degrees. So as I move my stick, now this servo default is set for 60 degrees, plus or minus 60 degrees for plus or minus 100% travel on the transmitter. So with my stick fully my throttle stick in the full position, full throttle position. I've got plus 100% travel as far as the transmitter is concerned, and that equates to 60 degrees on the servo. And if I go the other way, I've got negative 60 degrees set. And we'll see that later when we have a look at the travel adjustment for this servo. There's another interesting parameter for the servo, which I might display just for curiosity's sake, and that's we've got rate. So this rate parameter gives us a rate of degrees per second. So that tells us how fast the servo is moving at any instant in time. So, and you see, oh, how do we read that? So don't forget we've got a min-max function. So you can see just me moving the stick there, I've got around about 466 degrees per second. Don't forget all these telemetry parameters are recorded for each flight, so you don't have to have a widget displayed to be recording all these variables. So you can imagine if you've got a whole bunch of these servos in your aircraft, you don't want to, populate multiple screens with, every single telemetry parameter for the servo, because you're going to, have a ridiculous amount of data to be displayed and viewed and interpreted by the pilot. And you just don't really need that. A lot of the times, I don't bother with displaying a lot of these telemetry widgets for the servos, for instance. So I'll refer to them later at the end of the flight when I download the log, say for that flight, and then, have a look at the actual log file and then have a look at those parameters. So again, you don't need to have a widget displayed. Okay, let's have a closer look at the programming. So to get into the programming menu, basically press on one of the widgets until you see it started wobbling around. Press it again. And now we presented with a preliminary menu. So here we can set alarms, audible alarms, etc. I've done a video on that before for telemetry sensors. You've got the actual sensor here. So you can click, whoops, sorry, I should have long press on that. So long press on this box here. You can change the name of the servo here. So for instance, if this is an aileron servo, maybe aileron 1 or something, you can actually type that in there if you want to. That's just the default name. So out of the box, all the servos come labeled like that. But the more important thing is this address here of 5. So when you buy iServo and you buy, say, 10 of them, each one out of the box will be set to address 5. And that's the address that's used by the device on the P2 bus. It's a unique address for servos, so only servos will be using address 5 to start with. So just be aware that if you're using multiple servos, if you attach 2 of these servos to the bus, the P2 bus, and they both have address 5, you'll get a clash and you'll get some weird results as far as the telemetry sensors are concerned. So you need to change that address, and I might as well show you how to do that right now. So once you're in this menu, all you need to do to change the address, so if we're going to add, say, another servo, you want to change the address of this servo, just basically push this button once, this address button, wait a couple of seconds, because it basically rescans the bus, and that's it. The address has now changed. If you want to verify it, you can long press on here. You'll notice now it's set to address 200. So address 200 and onwards form part of the free user addresses, if you like. So whenever you have a telemetry sensor, so don't forget, as far as the system is concerned, this is treated like any other telemetry sensor. If you increment or basically change the address, they'll start at 200 and go upwards. And any other sensor that you have, and you want to put 2 of the same sensor on, you need to change the address. So if you use this method, I should say, the system will automatically pick a free address, sort of 200 and above. And again, I can show you, push it again, wait a couple of seconds. Let's check the address now. You'll notice it's incremented to 201 because that was the next free address. Addresses below 200 are usually reserved for the default factory address of a sensor. So for instance, if I have a voltage sensor, you might find that out of the box, you buy one sensor, it's set to address, say, 40. If you have two voltage sensors, the second sensor will also be set to address 40 when you first connect it to the system. So you need to change the address of the first sensor, say to 200 or 201 or whatever the next free address is, and then connect the secondary sensor. So if you have different sensors, this doesn't apply. It's only if you use two of the same sensor or two or more of the same sensor. So again, these are treated like a telemetry sensor. So out of the box, every PowerBox iServo sold will have address 5 set as its basic address. And if you're using more than one in your aircraft, you need to change the address. So that only applies, of course, if you're using it on a bus system like the P2 bus. If you're using it as PWM, you don't have to worry about it. If you want to reset the address back to default, all you need to do is long press on this little box. And again, just wait a few seconds. Let's check the address now, and it should be set back to 5. There we go. So this address, don't confuse it with the actual channel that we're using, or the transmitter channel, if you like, for the servo that we're using on the bus. So at the moment, this is set for channel 1. So on the P2 bus, so this cable here is just connected to the P2 bus, and that sends out all channel information from the transmitter. So the transmitter is transmitting all 26 channels, and all that information is on this bus line basically continuously, but the servo is only responding to channel 1 because it's set for channel 1, and we'll see that in a second. Okay, let's have a look at the menu that's within the actual servo. So to access the programming menu, we just basically short press on this little menu icon here, three little horizontal lines. And now the transmitter's reading the servo basically. So let's see, what's it tell us? Well, it's got firmware version 3.3. We've got a settings button. So these two buttons here, the left-hand button doesn't seem to do anything. So whenever we change a parameter, we need to save it into the servo. So you just basically long press on this right arrow, or short press on it, I think. And we'll see, we'll do that in a second. And that'll save the parameter. Now, control channel. So this is what I was talking about just now. So this control channel is set to channel 1. And notice there's a little A after it, alpha character. And here we can set what channel we want the servo to respond to on the bus. So remember, I'm using a core for this example. So we have 26 transmitter channels to choose from. So yeah, we can pick whatever channel you like. And then the servo jumped in because I've got some channels programmed in the transmitter at different settings. You notice the little alpha characters moving as well. So don't forget, on the larger power boxes and even on the receivers, PowerBox give the channels not only a number, they also give it an alpha character. So channel 1 is A, channel 2 is B, channel 3 is C, etc., etc. Okay, servo disengage and learn neutral position. If you watch my last video, I did explain these, but we'll get back to these in a second. I want to move to neutral position. So before we do, let's put my stick or the channel into neutral, or located at neutral. So neutral's 0% travel. So that's basically mid stick, if you like, which I'm calling neutral. Let's go back into the servo. Let's go to neutral position. So this basically becomes our sub-trim for the servo. So with servos that are programmable, usually we can set an offset for their neutral position. So obviously you can use sub-trim in your radio, but I also like doing it in the servo as well. So I really like it where I might have a particular model, and you might find that positioning the arm on the spline, you just can't quite get it at 90 degrees to the control surface or the control arm or whatever you're connecting it to. You might be 95 degrees or whatever. It's just not quite there, and you need a little bit of sub-trim to make it exactly 90 degrees. Well, you can do that in the radio, or you can do it here as well. I like doing it in the servos if it's available, because then I can just set my transmitter to 0% for the center neutral position. It's just easier to remember. So all you need to do here is just basically click the box, and you'll see the horn start. If we hold it down, it starts moving quicker and quicker. So let's put in about 20 degrees offset. And at the moment, our neutral's now been offset by 20 degrees. So if I save that, let's save that. So remember up here, button to save, right arrow. It's now saved, shows saved there. So that's now saved in the servo. All good. So now, if I go back to our home screen, we still have our normal plus or minus 60 degrees from the neutral position. So the new neutral was offset by about 20 degrees. So if I go to 0% there, that's basically our neutral position for this servo. Fairly simple, self-explanatory. And you'll also notice that in the widgets, you'll see the position widget is set to 0 degrees. So that's offset as well. So everything reads correctly. So basically that's our new neutral position. Again, really handy for aligning servo arms up to their control rods or whatever you're using to move, whether it's a rod or an arm or whatever, another arm. You can set perfect 90-degree action where required, or 45, depends on what you're setting up. Okay, let's go back now. Let's have a look at this servo disengage. Now, I did cover this in the last video, so this might be a bit boring for those that have watched the last video more than once. Now, I just showed you how to save the neutral position using these two buttons. 9 times out of 10, we do it that way. It's pretty simple. Sometimes you might find that you can't quite view the servo horn or whatever, and you want to do it mechanically. You might want to move the flight surface or whatever. We can disengage the drive to the servo. So at the moment, if I try and move the servo, it won't let me move it because it's powered up. It's holding neutral. However, I can deactivate the motor. So now the motor's deactivated, I can now physically move the servo, even though we still have power applied to the servo. And say we want the new neutral to be over here somewhere. I don't know how many degrees that is, but it'll show us in a second. So I put it over here and I've lined everything up, eyeballing it. Looks good on my aircraft. And I'll say, okay, I want to save that as my new neutral position. So all you need to do now is go activate. And you'll notice here the neutral position is now changed to negative 50 degrees, or negative 50.5 degrees. Because that's the new offset from its inherent neutral. So don't forget, the servo knows that its standard or saved neutral, normal neutral, is straight up and down. I think before we move the horn. But now it's set to negative 50 degrees. And again, don't forget to save it. Now, I do this mistake all the time. Don't forget to deactivate the disengage function, because if you move your stick now, nothing happens. So you've got to deactivate the disengage, so basically make it active again. So the servo now works. And now if I go back to the home screen, minus 100, plus 100, let's have a look at our new center or neutral position. It's now offset, whatever it was, 50.5 degrees in the negative anti-clockwise direction. Simple as that. So that's a real handy feature, and really only possible because this is a Hall effect servo. It doesn't have a potentiometer. Okay, let's move on to some of the other features. Again, I covered most of this in the previous video, so some of it might be boring to some of the viewers, so I apologise for that. Now we have our travel. We've got clockwise and counterclockwise travel. At the moment it's set to plus and minus 60 degrees. We can change those parameters. So this sets our endpoint when the radio is set to 100%. So this is not a physical endpoint, it's an electronic endpoint. And these pertain to a core and atom radio when they're set to 100% travel. So if I put, say, I don't know, let's put in 40% here, or close to 40%. Let's make it spot on 40%, and let's make this one higher. So in the anti-clockwise direction, I'll say let's put in 100 degrees travel. I save it. Oops. It's a bit sensitive to my stylus, so let's save that. So remember, 40 and 100. So we've got 40 degrees in the clockwise direction. So I think that's when my stick is in the forward position, and then in the backwards position, the counterclockwise or anti-clockwise rotation, we have 100 degrees from the neutral. So don't forget neutral's over here at the moment. Let's go back to our home screen. So we're at neutral. If I go low stick, so I'll go full low stick, so negative 100. Gives us that much travel, which is 100 degrees. Go back to our center or neutral, which is 0. Move to plus 100%, and now we're only getting 40 degrees travel in the opposite direction. So those two parameters just simply set the travel relative to 100% that's set in the transmitter. So don't forget, on a core and atom transmitter, 100% is not the same as 100% on a Spectrum or a Futaba radio or any other radio. They are different. Even Spectrum and Futaba are a little bit different from each other. The PowerBox radios can go up to 200% travel. They do have extended range. So a lot of people are unaware of that unless they've played with one of these radios. So again, those travel parameters that are set in here pertain to a core and atom transmitter when the channel set to 100% travel in either direction. Okay, now, actually before I move on to speed and torque and that, I'll go to the next screen and I'll just quickly reset this. So 3 times button to reset, factory reset. I showed this in the previous video, so you basically click on this 3 times. It's now reset. So it's reset our neutral back to where it was. Now remember earlier I'd moved the horn. So let's put it back over here to give us a rough idea where neutral is. Let's move back to here. And you'll see the travels are now set back to normal, plus or minus 60 degrees. Oops, I had the stick in the wrong spot, didn't I? That's center stick. So sorry about that. I didn't have my stick in the center. I had it full throttle. So now that's at center stick. Let's have a look at speed limit. So speed limit is basically adjusting the speed of the servo. So you notice it's set to 1,800 degrees per second. And that's actually very fast. It's crazy fast. It's not, basically that's the maximum speed of the servo. Not the 1800 figure, but basically that's just the maximum you can set in the radio. So if we reduce this, we can actually reduce it down quite a bit. So remember, this is in degrees per second. So it's not a time or anything like that. It's just a number of degrees per second. So you could, for instance, set, I don't know, 60 degrees per second. So that means it'll take 1 second to sweep 60 degree arc. I'll just reduce it down to, I don't know, if I hold it down and now speed it up to its maximum decremental rate. Let's go down to somewhere around 100 or so degrees per second. Almost there. Let's make it 90. So now set it to 90 degrees per second. We can activate or deactivate this feature. So you have an option of toggling the feature on and off. So let's turn it on. So notice a little green tick box. Let's save it. So it's saved in the servo. It's now saved. So let's move the throttle stick now. So if I go from one extreme, I'll probably show it better on the home screen. And you'll notice the rate here will show roughly 90, 88, 89 degrees per second, because that's what we're limiting it to. So we're moving 60 degrees either side of neutral, but at 90 degrees per second. Cool. I'll leave it on that slow speed for the later example in regards to travel as well. So I'll leave it on slower speed at the moment. Let's go back into the programmable menus. What else have we got here? We've got a torque limit. So I mentioned this in the previous video as well. So we can toggle it on and off, turn it on. Maximum torque, we can reduce this figure down to 25% from memory. So that'll give us 25% torque maximum. So basically, this might be handy for certain retracts, or some applications where you need to limit the torque so it doesn't break something or overdrive linkage or something like that. So you can limit the amount of torque after a particular amount of time has elapsed. So here we can set a delay. So I think the minimum is 0.1, 0.2, the default is 0.5. So after half a second, the torque is limited to 25% of the maximum. And again, you have to save it. So I don't really have a setup where I can sort of demonstrate that, but maybe I'll have to rig something up with a current meter and some mechanical arm or something at some stage, but you basically get the picture. It's basically a torque limiting function. We also have a soft start, so we can turn the soft start on and off from here, from the transmitter. So that's really handy, especially for 3D aircraft where you have wild throws on your elevators. You know, you've got large elevators, large ailerons, large rudders. You know, you pull it out of your car, set it all up, and the flight surfaces, say maybe at full scale deflection. You turn the model on, and the servo snaps back in the center. Might give you a bit of a fright. It's handy having a soft start where you can slow the servo down, so this, you know, the flight surface goes back to its center position or neutral position nice and slowly. You can turn it on and off from here, but you can't adjust the time from here. However, using the PowerBox iServo PC terminal program, we can adjust the speed of this soft start as well, the time. And I'll show you that in the next video, so I'll cover that bit of software in the next video. So that'll be an interesting video, it won't be as boring as this one. All right, what else have we got? Back to this travel. So, remember how I was saying in the last video, or even in the first video, this is a Hall effect servo. We don't have any mechanical stops as such. So I've got it on slow speed, that's fine. And we've got plus or minus 60-degree travel for 100% throw on the radio. Let's do something a bit crazy. So I'll go back to roughly center stick. Let's increase that. Let's say, I don't know, let's make it, what can we make it just to show you? Let's make it 180. Be easier if we can type in the value directly. But usually once these figures are set, you don't have to play with them very often. So I think we're probably pretty close enough for this example. I get pedantic with figures. I used to do a lot of calibration of equipment. So I get fussy with decimal points. So 180, and let's do 180 in the other direction. So basically what this is going to do is move the servo horn 180 degrees from neutral in one direction, in the clockwise direction, and 180 degrees in the opposite direction. So this could be handy in situations where, you know, you've got some weird surface that you need to control and you need a lot of movement, and you might need the horn to actually move 180 degrees. So let's save that. All right, so got plus or minus 180 degrees. So that means the horn, when we move the stick in one direction, we'll move, say, clockwise all the way to the bottom of the servo. And then when we go the other way, it'll go back to neutral, and then go all the way back the other way. So in effect, it's going to be doing one full rotation for the full plus or minus 100% travel of the stick. Let's try it. Let's go counterclockwise first. Let's go back to the home screen as well. So got minus 100 there, got 180 degrees of travel in the negative direction. Now I'm going to go to full throttle, so plus or minus 100%. So try doing that on a standard servo that has a potentiometer in it. Just ain't going to happen. Alright, I'm going to go roughly center stick again. Back to sort of roughly neutral. Let's do something a bit more silly. Let's let's increase the travel even further. Let's go a bit crazy. Let's go to, say, 720 degrees. Now you'll notice the servo start to go a bit crazy in a second because we're basically increasing the range, and I'm at neutral. I should put it in end stop. 718, 720. So let's go full stick. So basically from the neutral position to full stick, in other words, in the clockwise direction, plus 100% travel as far as the radio is concerned, I'm going to get 720 degree rotation out of the servo. And if we do the same for the opposite direction, so this will give us a 720 in the opposite direction. So another two full rotations in the opposite direction. So, oops, 730, that'll do. Close enough. Let's save it. Let's go back to the home screen. So I've got 720 in one direction, or close to it, and 730 in the other. So if I go from plus 100% to minus 100% travel, this will go from plus 720 degrees to minus 730. So in other words, we'll do 2 full rotations to get to neutral, and then another 2 full rotations in the anti-clockwise direction to get to negative 720. Let's try it. Now remember, I've got the servo slowed down at the moment, so it's not doing its full speed. There you go. And yeah, you can do something silly, like you can put in quite large values for the rotation. So you could use it as a winch. So there might be some application where someone wants the continuous turning of the servo. That could be handy. But in this case, it's just something that you can do with a servo that features a Hall effect sensor versus a potentiometer. Because again, potentiometers have a mechanical stop. There is no mechanical stop with a Hall effect sensor type of setup. Okay, I think I covered all the parameters in here. Covered the neutral, learn neutral and all that. Let's have a look at the next screen. So we have the performance type, and I'll explain that in a second. I showed you the factory reset. So again, just hit the button 3 times. The servo basically becomes reset. So there you go, it's just reset. So if I go to center stick, and now it's back to normal full speed again. That's about roughly center stick. Shows us the P2 bus, so that's the default address 5, if you remember from earlier. Now this performance type, I did mention it in the last video, and we have a couple of different options here. You've got standard, performance, accurate, torque, and competition. I'll explain these values or the differences between these values in the next video, because when I go over the terminal program for the PC, for the iServo, has a little graph in there, so it'll make a lot more sense. But basically, you can imagine it really just changes the application of torque and also the deadband. So the main thing is the deadband. These different values between, say, performance, competition, accurate, really alter the deadband width for the servo. Accurate will probably give you the best performance around center stick, and then you select performance, you might get slightly a looser deadband, or it could even be tighter. I can't remember, I'd have to look at the graph again. You've got standard. Out of the box, they're set to accurate, so just be aware of that. That must be the default sort of good all-round, good guy sort of performance metric. Okay, and I think that's about it. Yeah, this video is probably a little bit boring. The next video will be a lot more interesting, because I'll go into the terminal program, the PC terminal program for these PowerBox iServos. And that has a few extra parameters in it. Actually, one other parameter, I just thought of it, is the failsafe. So for those of you who are not aware, most serial devices like servos on S-bus, even the P2 bus, you need to be able to save the failsafe to the device. So for instance, if you're running PWM, the receiver stores the failsafe data and it feeds that out via the PWM port. But it can't do that because of the way the P2 bus and all serial bus systems work. they don't sort of work in a similar way. They can't sort of send failsafe data to the P2 bus or along the P2 bus in a bidirectional format. So when you have a device that's being set for failsafe, you can't set the failsafe unless the actual device can store the failsafe position in its own microcontroller. So these servos now have the ability to do that. So I'll just demo that. So at the moment, I haven't sort of set any failsafe. So if we go into the function menu, and you'll see I've only set up one function for this. If we're going to failsafe, let's say set the failsafe position to over here somewhere. So I'll teach that. Say OK. Okay. So you're flying along, and in theory, when it goes to failsafe, the servo should move over there somewhere. So let's prove it. So let's go to full throttle or plus 100% travel. Yeah, probably easiest way is if I just change models temporarily. So if I go to the demo model, so you notice that's now gone into failsafe, and it's actually holding it. So I've got it set to hold in that position, so the servo won't move. So it's a fixed failsafe position. There's a few options for setting the failsafe, and you'll see that again in the next video where I'll show you the PowerBox iServo PC terminal program. So the failsafe works, and I've even tried it by we're in this wrong model, and if I disconnect power, so I'll just disconnect the battery. So if I've got no power going to the servo now. If I reconnect the receiver's not going to bind because I'm on a different model. However, once the receiver powers up, you'll notice, and the servo's initialized, it still goes back, it remembers its failsafe position because it's stored in the servo. So that's good to know. I'll go back to our test model.
Test model loaded.
And yeah, we're back to normal now, so we should have normal configuration. And the telemetry sensors are found, so got our normal readings again. So that's an important feature that wasn't available on the previous PowerBox servo, the iServo 5, I think it was. You didn't have the ability to save failsafe in the servo, whereas now with these new servos, you can set failsafe in the servos. I was specifically asked that question in an earlier video. And yeah, it does work, it works well, so no problem there. So that, again, that's a real handy feature if you're using a P2 bus configuration. Okay, thanks all for watching, and like I said, I promise the next video will be a lot more interesting because we'll cover the PowerBox PC version of the iServo terminal program, and that's a specific program just for programming these servos via the PC. There's quite a few cool little options in there. There's even a little test mode thing, and yeah, I'll cover that in the next video. I'll catch you all then. Thanks for watching.